Okay, so I'm going to be talking about the Austevoll digital twin, or the work in progress thus far. And I'm going to be talking about it in the context of the digital twin being a data consumer of the SmartOcean platform. So first of all, what is a digital twin and why should we use it? In its simplest form, a digital twin is kind of like a copy of a physical system. A copy where you model all the interesting attributes or properties of that physical system such that you can do some easier testing or simulation scenarios. Also, that you can get real-time monitoring and overviews from different types of viewpoints and perspectives. And you also get, with the digital twin, you also get the ability to automate changes on the physical system based on the processing of data happening in the digital side. So why should we use one for the Austevoll site, for example? Well, the Austevoll site serves as an inspiration for example, using digital twins to control clusters of fish farms because we could be using some similar data, some similar underwater data and properties coming in. This could, of course, help us a lot with, for instance, optimized production, but also the limiting of the spread of sea lice or other disease. How do we make a DT though? Well, the following is kind of a prototype checklist, a very basic one. Of course, one needs to model the physical system in some way. So you need to extract kind of all the interesting properties of the physical system to have in the digital side. You also need the sensors for the data collection, so kind of like we already have in the Austevoll site underwater. We need the corresponding infrastructure, something that's going to host the digital solution for us. So something that's going to be either like a server or a cloud that's going to be running some kind of data processing, handling the model, and so on. We need a sensor network connection, so something that's going to be sending the data or ingesting the data that's going to be used by the digital twin instance. Following that, we also need a data processing module, so something that's going to be doing some kind of optimizations, perhaps testing, etc. And lastly, we need some kind of user interface or kind of like a control center for the end user to be able to not just overview, but maybe make changes on the physical system from the digital side. So this is often referred to as a DT cockpit. Instead of diving kind of headfirst into it and trying to make a DT from scratch, it's important to consider what kind of tools already exist. So maybe we can find some kind of frameworks or something that helps us host digital twins or at least create them in part. And for this, we opted into exploring the Azure-based solution from Microsoft. They offer a digital twin instance creation and hosting in the form that I'm showing here. So this is kind of a generalized architecture of what a digital twin looks like in Azure. It begins leftmost with the IoT hub component, so the Internet of Things hub, which is effectively the data ingestion part of the DT. This holds all of your registered devices or representations of devices in the real world, which then basically act as metadata providers for when the IoT hub further sends messages or other data to the Azure function. The Azure function, which is the middle component, acts as the data processing module. So this is effectively where the logic is in the system. And further on from that, we have the actual DT instance or the representation of the DT model itself. Integrated together with the SmartOcean data platform, our thus far rudimentary solution looks like the following. So on the left, we have the SmartOcean data platform, which provides data coming from the physical sites via the HiveMQ messaging broker. And on the right, we have the solution that's currently hosted in Microsoft Azure. Notice that although I mentioned that the IoT hub is the ingestion point for a DT, in this case we had to do a workaround by going directly to the code portion or the logic portion to a component that we call MQTT bridge due to some limitations in how Microsoft handles MQTT subscriptions. But nonetheless, going from the MQTT bridge, we see that messages are forwarded to the IoT hub as they usually would be from the HiveMQ broker, and then from then on, the rest of the chain is the same. So the IoT hub would send an event containing certain device metadata as well as the message itself to the Azure function. The Azure function then extracts the relevant information and all the properties that have to be updated in the DT model, and then it creates a DT patch document that it sends to the DT instance, which then reflects the changes made by the incoming data. Last but not least, I want to show you a little bit of an overview of what it looks like to use or to monitor DTs in Azure. So as you can see, there's a lot of different components here. Most of these components are actually infrastructural. There's some glue holding the three main components together. Some things are required for hosting and so on, but the most important components are the IoT hub, the Azure function, and of course the digital twin instance. I'm going to go ahead and show you what it looks like from the cockpit, which is represented by this Azure Digital Twins Explorer. So just very briefly, this Digital Twins Explorer gives us an overview of the digital twin and the data in the twin. So on the left-hand side, we can see a representation of Austevoll South. So that's one digital twin component that we have. If I run the query here to fetch the digital twin for me, we'll see that there's a single component available. You should note that this is just a rudimentary graph-based representation. You can create multiple components, chain them however you like in a graph, but you can also have 3D scenes that maybe more accurately represent the physical environment for your incoming data points. But if I go ahead and click on this, then on the right-hand side we can see all the different properties coming from the various sensors and all the different data points being updated in real time or near real time. And that's about it. So thank you for following and have a great day.